Hi, my name's Bob Taylor, and I'm the creator of these Flutter Embedded YouTube tutorials. I've got about 20 years of experience creating custom embedded systems, and the normal way of doing this using C, C++, and Qt, while it works and it's effective, it can also be very expensive and have per unit costs. And then trying to match your user interface up with your app and your website can be a real nightmare and require massive teams. I think by using Flutter in the embedded world, you can leverage the power of Flutter's user interface and Dart as the object-oriented language to handle all the controls, and dramatically reduce your cost and complexity of creating a complete IoT system. App, web, and embedded touchscreen interface can all look very similar and work like an iPhone or work like an Android phone. So with that in mind, I've enlisted the help of a 3D character, and I generate the text that's converted to AI speech so that I can get this content out to you clear and concise and quickly. So if you have any questions or comments, please send them to me and I'll get back to you in probably a day or two. But thanks for subscribing and smash the like button. And without further ado, I'm going to hand it over to my virtual assistant, Bill, and let him take the class from here.
In this tutorial, we are going back to the UART screen Dart file and finish our user interface. We will add to our UART screen state the code to initialize the UART service class, create an empty list of strings for our received UART data, and set up our text editing controller. Next, we'll code our lifecycle methods. The initState method starts the UART service and listens to the data stream, and the dispose method handles freeing up resources when called. We'll now code the custom sendData method that we use to send data via the UART service. Our user interface will consist of a scaffold, an AppBar, and some padding with a column as the child. The column will have widgets as children. In the column, we have the text field for user UART data input. The ElevatedButton is our send to UART button. The expanded widget allows its child, the ListView, to fill the available space allowed by the column. The ListTile shows the incoming UART data in a list format. To handle state management, we'll use the setState method. This will be used to update the UI when new data is received. Follow along with me as we create a new TextEditingController object and assigns it to the variable _controller. I'm going to put in a comment and then paste in the code. Let me explain our code. TextEditingController. This is a class in Flutter that is used to manage the text being edited in our UI text field. _controller. This is the name of the variable that holds the instance of TextEditingController. TextEditingController. This calls the constructor of the TextEditingController class to create a new instance. This code sets up an initial state for a widget and listens to data from UART service. At override void initState, this method is called when the widget is first created. UART service. Starts listening for data from UART service. UART service. Data stream. Listen, data, listens to the data stream from UART service. setState, receive messages.add, data, updates the UI by adding new data to receive messages whenever data is received. Next, we create the dispose method. This code cleans up resources when the widget is removed from the widget tree. At override void dispose, this method is called when the widget is being destroyed. UART service. Dispose, stops and cleans up the UART service. _controller. Dispose, disposes of the _controller to free up resources. Super. Dispose, calls the parent class's dispose method to perform additional cleanup. Now we can code the _sendData method. This will send data entered by the user through the text field. Void underscore sendData defines a function underscore sendData to send data. String message equals underscore controller text retrieves the text from the underscore controller. If message dot is not empty, checks if the message is not empty. UART service.sendData message sends the message using UART service. Underscore controller.clear clears the text field after sending the message. Now let's build the user interface. We'll start with a scaffold that provides the basic structure and includes an AppBar. In the AppBar, we will only use the text widget and center the title. In the text widget, I will title the app, Raspberry Pi UART Communication. Feel free to name your app whatever you like. Now we can add the center title. This requires a bool of true or false. We will use true. The center title will center the AppBar title in our app. For the body of our UI, we'll start with a padding widget, and assign 10 for our edge insets. The child of the padding widget is a column. The column will have widgets as children. Now we'll create our column and assign it to the type of widget. A column creates a vertical layout of widgets. Let's code our text field for our user to input UART data. Here is a brief explanation of the code. TextField creates a text input field. Controller links the text field to controller to manage the input text. Decoration input decoration adds a label and border to the text field. For the label text to prompt the user, we'll show send message. For the border, we'll use outline input border. I'm adding the commas so that the code will format properly. After saving the file, you can see the formatting and auto-generated Flutter comments. For spacing, we'll use the sized box with a height of 10.0. Now we can code our ElevatedButton widget. We are creating an ElevatedButton to send the user inputted UART data. The onPressed part of the ElevatedButton calls the _sendData function when pressed. The child of the ElevatedButton, text, sendData, displays sendData text on the button. To space the UI widgets, we'll use another sized box with a height of 20.0. Our next part of the UI will be for UART received data. We'll create a text widget and add the string received data. Remember to add the commas and then save the file. For the UI layout, we'll use expanded and the child will be the ListView.builder. For the item count used by the ListView.builder, we'll use the length of the received messages list. The item builder for the list view takes the context and the index of the list and creates the list of scrollable received messages. Now we can return the ListTile widget and show the UART received data in the ListTile title. I am checking to see if we have critical errors and there are none. The warnings can be fixed later. Just about ready to test our app. But first, let's update our JSON file to make it easier to debug. Click on Create a JSON launch.json file. In the launch.json file, copy what I am doing and then save the file. Now you can see the UART debug mode. Click on the green arrow to start your debug session. In the Select a device to use, select Linux Desktop. On my Raspberry Pi Model 4B with 8 GB of RAM, it took about 2 to 3 minutes for the first build and debug session to start. I cut out the waiting time and jumped back in when the build was nearing completion. Here is the finished user interface. To send data, enter it in the Send Message text box and then click or press the Send Data button. Your code will then send data to the Raspberry Pi UART and on out to an external system. When data is sent from an externally connected system to the Raspberry Pi UART receive pin, your code then displays the data as strings on the user interface. Now you can build off of these foundation principles and create your custom IoT system using Flutter. Congratulations on completing your Flutter Embedded UART app. We hope you enjoyed this tutorial. The source code, equipment list, and other info are in the description. The links in the description take you to the equipment that we recommend. Using this tutorial series, you can expand on the basics and create your own applications for SCADA, Modbus, and TTL to USB serial communications. Thanks for watching and stay tuned for our upcoming tutorials.